Alright, so in this video we have our lesson 4. It's the Poisson distribution. So when we say Poisson distribution, the other experiment which yield a number of outcomes that occur during a given time interval. So remember the difference between the binomial distribution, which consists of repeated trials, while the Poisson distribution, it is a time interval. So this time interval may be any length, such as minute, yeah, given hour, a day, a week, or a month. And experiments such as this, where are time dependent, are called Poisson experiments. So example, the following are the number of telephone calls received per hour, the number of volcano eruptions in a year, the number of car accidents in a week. So those are example of a Poisson experiment. So receives per hour, eruptions in a year, yeah, accidents in a week, like that. Okay, so a Poisson experiment possesses the following properties. The number of outcomes occurring in one interval is independent of the number of outcomes that occur in the another interval. The probability that a single outcome will occur during a very short time interval is proportional to the length of the time interval and is dependent on the number of outcomes occurring outside the time interval. The probability that an outcome will occur more than once in a short time interval is very negligible. Okay, so we have here the number of x of outcomes occurring a Poisson experiment is called Poisson random variable, and its probabilities depend only on the average number of outcomes during in the given time interval. So the probability distribution of the Poisson random variable is given by this formula. So P, this is the mean, the x and the mean. So E, which is this constant, is just pi. There is a value for that one. And e raised to negative mu raised to x over x factorial. For x, remember how for x is equals to 0, 1, 2, 3. Okay, so starts from 0, 1, 2, 3. Or since we have here, as you can see here, the law of exponent or the law of negative here, if we have negative exponent in the numerator, when we're going to transfer it in the denominator, it will become positive. Okay, so it could be like that. Then we have here the e. Use 2.718, that is our constant. Substitute e by 2.718, the base of the natural logarithm. So let's start with the example. The average number of time in a week a machine is closed due to top brownout. Is this top brown? Anyway, basta a machine closed due to brownout is 4. So meaning, what is this for? We already have the given, the mean is 4. What is the probability that a machine will close for 6 times in a week? So this times in a week, that is our capital letter X, that is 6. Okay, so by the given of the Poisson distribution, so using the formula, mu raised to x over e. Okay, so we have 4 raised to 6 over e raised to 4, 6 factorial. So we have 4096. Again, how did we get this? The base of the natural logarithm. Okay, so again, go back to 6 factorial. That is 6 times 5 times 4 times 3 times 2 times 1. And then simplify, that is 0.1042. So what is this? Please make apelido. The probability that the machine will close 6 times in a week. Okay, so that's it. How about second example? On the average, a certain intersection results 3 traffic accidents per month. The average, the clue. What is the probability that in any given month at this intersection, letter A, exactly 5 accidents will occur, and letter B, less than 3 accidents will occur? So let's start with letter A. Exactly. When you say exactly 5, so that is 5. So your mu or the mean is 3. And what is your x? X is 5. So by the formula, substitute. So you have e raised to negative 3, 3 raised to 5 over 5 factorial, and then the denominator, that's why it's become positive here because it was transferred to the denominator. So e sub 3, e raised to 3, 5 factorial. So again, e, substitute by natural logarithm, we have 2.718 raised to 3, and 5 factorial, that is 120. Okay? How did we get 5 factorial? Is 5 times 4 times 3 times 2. So 5 times 4, 20 times 3, 60, and that's why we have 120. And then you substitute that one, then we have 0.1008. So that is the probability that exactly 5 accidents will occur, given that the average of a certain intersection results in 3 accidents per month. Next, we have letter B, the probability that less than 3. So when there is a clue here, less than 3. So what are the numbers less than 3? So we have 3, 2, 1. Do we include 0? Yes, because go back here, for x is equals to 0, 1, 2, 3, and so on. Okay, so that's why we are going to include 0. Meaning 0 here, there is no accident. So that's why we have to less than 3. 3 is not included because it's not less than or equal or at least. So less than. Yeah, we have at least, we have at most. Sige, I'm going to define it at least 3, at most 3, greater than 3, less than 3. So if I'm going to change this one into mathematical sentence, at least 3, that is x greater than or equal to 3. Okay, that's why 3 is included when you are talking about at least. And when you say at most, we have x is lesser than or equal to 3. Okay, when you say greater than 3, so x is greater than 3, and less than 3 is x is less than 3. So take note of these following words because mostly it will be given to you in this kind of problem in Poisson distribution or in the binomial distribution. So take note of these 3. So the probability that less than 3 accidents, we have here x is equals to 0, x is equals to 1, and x equals to 2. So by this, we have Poisson 0, 3, Poisson 1 and 3. So by substituting the formula, so you have here, so e raised to negative 3, 3 raised to 0, 0 factorial. And then remember that it will become negative, it will transfer to the denominator. That's why we have e raised to 3, and then substitute it by the natural logarithm, which is 2.718. Okay, so and then by simplifying that one, you add those answers. So we have 0.4233. So this is the probability that less than 3 accidents occur. Okay, so please take note, do not forget to put pilido, ha? The probability that less than 3 accidents occur, given that, go back to the problem, given that a certain intersection, yes, we are going to go back to the problem because it is not the same if the average is different. So the answer is dependent on the given problem. So results in a certain intersection, results in the average of 3 traffic accidents per month. 3 traffic accidents per month. Okay, so that's it. Alright, so that is how we're going to answer the Poisson distribution. So if you have more questions, clarification, just PM me or comment in our Facebook page. Thank you and God bless.